GPU cluster one next door that I'm kind of regret I have to give this presentation, so I can't go to that one. My name is Catherine Holloway. You can find me on GitHub as Catherine H. And for 5 years, I was a PhD grad student at University of Waterloo. University of Waterloo's Faculty of Science offers a computational science degree. This is a cross-departmental degree that kind of focuses on everything that SciPy stands for. And for my time in grad school, I was the teaching assistant for the computational physics classes. And today I'm going to tell you about a Python package that I've been working on for the past year that is kind of inspired by my time as a TA for those classes. Now, every great software development story starts with a great user story. So for this presentation, let's imagine that our user is the undergrad freshman meme guy. Undergrad freshman meme guy is a computational science student. His programming skills are probably not as good as someone in the computer science department, but he's still really excited about science. He's also really excited about Quidditch. And the midterm for his class happened the day after the finals of his intramural Quidditch league. So he flunked his midterm, and now he's looking for some extra credit. And his professor says, all right, well, the midterm mark will be null and void if you make me a nice animation of your gravitational orbit simulation that you wrote as part of an assignment for the class. So our freshman undergrad knows nothing about drawing in Python, so he goes to Google. And so he starts looking for options. The first thing that he comes across is processing and Python mode. So as an introduction, processing is a project that came out of the MIT Media Lab in 2001. So processing is both the name of the IDE, the language, and the project. It's targeted at artists and beginners, so it has a fairly simple syntax. And the latest versions have a Python programming mode. So he looks up a tutorial to make a red spinning cube in processing, and he finds this code, and it's nice and easy. It's only 11 lines, and it's all readable and understandable to him. And this is the animation that it produces. All right, so he's happy. He's like, OK, I'm going to go on. I'm going to apply this to my simulation. So the next thing he does is import SciPy ODE int, because that's what he used to integrate the gravitational equations he was using in his simulation. And he gets import error, no module called SciPy. And this is very upsetting to him, because he is absolutely sure that he has SciPy installed on his computer. I mean, he's been doing all of his assignments in it. But what he doesn't know is that processing's Python mode is really just a veneer of Python over a Java virtual machine, and therefore it does not have all of the other lovely Python packages he is used to. So he goes back to the drawing board, or back to Google, rather. And the next thing he comes up with is PyOpenGL. So PyOpenGL is the Python binding, or one of the projects that's a Python binding to OpenGL. It's kind of like how what PyQt is to Qt. So he looks up the same sort of tutorial for a red spinning cube. He sees the import statements. It makes sense. He has to import the graphics library utility tools, and the graphics library utilities. He sees the next part that he doesn't really understand. This is about setting up some shaders and some lights and the camera in his scene, but it's like, well, that's not really related to drawing. I'll just leave that in my code and ignore it. Then he looks at the actual code for drawing a cube. Now, this is not the recommended way for drawing a cube, but it's basically the canonical example that comes up whenever you're looking at an OpenGL tutorial, which is just you draw a cube by drawing 6 quadrilaterals, one for each side. And to do that, you need to define 4 vertexes of each quadrilateral in 3-dimensional space, and you also have to define a color for that face. And just to show, the entire code just to draw a cube looks like that. But And then, in addition, you have to use the utility tools to actually create your window and display things to it. But it produces a nice spinning cube, kind of like processing. So undeterred, our undergrad's like, OK, whatever, I can learn this. I just have to learn OpenGL before next week, and I'll be good. So he goes to OpenGL's website and downloads the OpenGL cheat sheet, which is not actually a sheet. It is a 13-page PDF in 9-point font. He opens up the first page. The first page has nothing to do with actually drawing shapes, which is what he wants to do. It's all about buffers. Now, keep in mind that our freshman undergrad guy is a computational science student and not a computer science student. Therefore, he is not familiar with the concepts of buffers, of pointers, or even of types. So this is all a little too confusing for him. And he goes back to Google again and finds Piglet. So Piglet is also an OpenGL binding, but it's kind of a nicer, more user-friendly OpenGL binding. It has a bunch of modules that simplify windowing and a lot of multimedia stuff. And it will generate basically all the same stuff that PyOpenGL can do. So he finds, similarly, a tutorial for the red spinning cube. He looks at the import statements. This seems reasonable to him. He looks at the actual code for generating a window and drawing to it, and he can understand all of these words. So he's happy. OK, let's look at what we actually need to do to draw things. So he sees the same code that he saw for PyOpenGL, and now on top of that, there's this really scary @ symbol on top of it, and he does not even know what that does. And the drawing is the same, so he is upset again. So the final thing he finds is this module called VPython. Just to give some background on VPython, it was created by David Scherer in 2000 to replace CT, which was what Carnegie Mellon used in their computational physics classes. And then it was adopted by one of his profs, who was one of the original developers of CT. So its primary goal was for computational physics classes. And in the background, you have C++ actually calling OpenGL. And this is then compiled to a module. And they use WXPython to do the windowing. And this is actually used in several physics textbooks. And we have a actual physics prof in the audience, Matt Craig over here. And I'm very grateful to him for supplying this example. So this is a sample assignment of teaching Newton's second law, F equals ma. You have a ball represented by a sphere. You can give the ball a velocity. And then you apply the force of gravity, and you watch the ball move. It's basic projectile motion that you might remember from high school physics. And then it's really easy to show the summation of forces by adding the force of drag to the ball. And then this is an example of how it will actually render. You can add a trail to the ball and see the actual difference for yourself without having to toss beanbags in your physics lab. All right, so our freshman undergrad looks for some sample code to draw his cube. He finds this thing, which is really nice. It's 5 lines, and it's all understandable to him. So he goes ahead and writes his SciPy ODE and visualizer in this and uploads it to the physics marking server, which is running Python 3 and is an Ubuntu machine. And he thinks everything's good, and it renders correctly on his Windows laptop. So yeah, he's happy. Then he gets an email from his prof, which says, there is no Debian package for WXPython 3. Could you please come to my office and show me your assignment on your computer? And he doesn't really understand what this means, but he'll go into campus to his prof's office and show the simulation. And that's kind of a pain for him because his physics prof is a nice guy, but he has a tendency to go on and on about how great programming is and how great physics is, and he really just wants to go back to the soccer field and play more Quidditch, so that ultimately makes him upset. All right, so the point I'm trying to convey with this user story is that writing simple and easy-to-use graphics libraries that are also cross-platform is hard. However, there are already Python projects out there who are sort of domain experts in making cross-platform windowing and 3D drawing systems. So why should I, as a physicist, write my own OpenGL interface code when someone else has done it for me? So the idea I came up with to try to get around this problem is to write an OpenGL helper. So VPython has a really, really nice API. I really like it. It has everything that I want to do. But it's written in C++. But let's just use it as a guide. Instead, we'll use a Python OpenGL binding to do all the heavy lifting and all the interaction with OpenGL. We'll try to remove all this stuff about windowing away from the user. And then the next thing we have to do is decide between which Python OpenGL binding we're going to use. So at the moment, PyOpenGL seems to be the most obvious choice because it has more support for more stuff. However, I chose Piglet, and that's just because it has better documentation, and the extra submodules really make things easy. All right, so just to clarify what I've built, I have a submodule called objects that has basic geometric shapes in it. I have a submodule called utils, which has the mathematical primitives used to manipulate those shapes. I let piglet.gl interact with OpenGL, and then I use the Piglet window and app submodules to handle the display. All right, so I'm going to talk a little bit about some quirks in the implementation before I go on and show you some neat animations. So there are a couple things that I found when converting to C++, or from C++ to Python. It's not as easy as just doing a find replace on curly brackets. So one thing, for example, in C++, you can have multiple method declarations. So you can define a vector by passing it 3 doubles, passing it nothing, or passing a pointer to a double. And to make this Pythonic, what I did was use the get item, set item, and length operators for objects. So basically, as long as you pass it an object with length greater than 3, it can just assign that to the x, y, and z components of the vector. This means that you can give it a tuple, give it a list, or give it another vector, and it will just work fine. And if you don't pass it anything, it will just set everything to 0 like it did before. Another thing that I'm kind of iffy about was whether I should make the API meet the PEP style guide. And ultimately, I chose to make it meet the PEP style guide, but I'm kind of regretting my decision now. So for example, all the objects that were all lowercase became uppercase first letters, and then the Pylint or PEP style guide also does not like single character variable names, so vector.x becomes vector.x_component, or just grabbing the first element of the vector. All right, so given that I keep changing the API, how do I make sure that API changes don't break everything? And the solution is to use continuous integration. So I'm using Travis CI, which is free as in beer, but not free as in speech. So anytime I push a commit to the repo, it will run setup.py, install for Python 2.7 through 3.4, runs Pylint, and runs the unit tests. Now, this produces an interesting problem in that I want to do continuous integration on a graphics library. So OpenGL requires a display to draw to, but Travis CI runs on a headless server. So, and then my first idea was just, well, we'll render to a still image. And there are packages like XDummy that will purportedly let you render to a still image, but I have not been able to get this working. It seems to be something to do with the NVIDIA X driver. And if you know a solution to this or know of a project that has successfully used this, please let me know. There is an unanswered Stack Exchange question on the Ask Ubuntu stack that has been unanswered for 6 months, and I will definitely upvote you if you respond to it. All right, so the alternative that I'm working with right now is just to mock. So if you're unaware, in the mock library, there's a method called patch. And essentially, what that allows you to do is to replace every instance of a reference in a specific method with another reference. So in here, for example, I'm saying the box module will try to import piglet.gl as GL, replace GL with my Piglet helper test fake GL. And then in the fake GL module, I have the function primitives, but they don't do anything. And this is kind of cheating. However, right now my goal of testing is not really to test whether things rendered correctly, but just to test that the math is correct and that the API is correct. And if someone ever answers my Ask Ubuntu question, maybe I'll actually test that it renders correctly as well. All right, so finally to go over some Piglet helper functionality. So there are 8 objects. I can't count when I'm doing a presentation, apparently, that you can render right now. These are all the geometric primitives. And on top of that, there are objects called scene and light. So scene just contains all the information about where the camera is, what the shader is doing, and light stuff. It will just sort of set this up all for you by default. If you don't want to specify anything, or if you want to play around with the actual rendering, you can change the variables there. Lights are non-renderable objects. And then you can either add objects to a scene, or you can create an object first and then pass it a scene when you actually want it to draw. So this is what I mean by that. So you can either create your box, create your scene, then pass the scene to the box when you render it, or you can append the box to the list of objects, and then when you set up the scene, it will render those objects into the scene. And then finally, just to simplify all of this to the user, I have one method called vSetup that will actually even do the work of setting up the scene for you, and then anytime you create a new object, it will just add it to that scene. And then I also have a method called vrun, which will actually create the window behind the scenes, render all the objects in it to the default scene. And then a utility that I added to that, which was very helpful to me, is just to give an option to render an image every time update is called. And that is very useful in creating nice animated GIFs to put on my Twitter feed. And yeah, you can specify the max frames and the interval. And that's what the spinning cube example looks like in Piglet helper. All right, so I'm going to say something a little bit heretical at this conference, which is that I do not like or use Jupyter notebooks. However, I have heard that there are people who do. And so I started this project last year, and this was my approach to making visual work again, was to strip out the C++ and replace it with Python. The original developers also wanted to solve this problem, but they solved it in a different way than I did. But they tried to solve the problem for the same reasons that I did, which is just WX Python seems to be going the way of the dinosaurs, and few people who like to develop in Python really like to do stuff with C++. So their solution was to create a JavaScript library that interacts with WebGL instead of creating a Python library that interacts with PyOpenGL or Piglet. All right, so they have 2 options for using this library that they've created called GlowScript. One is just to go online to glowscript.org. So you can write Python syntax in there, and it will render in WebGL. But again, you have no access to other Python libraries because you're running it. You're not actually running Python. And then the other option is there's this package called VPython Jupyter. And essentially what that uses is a 0MQ to transfer JSON between your Python kernel and the GlowScript WebGL library. And this is what it looks like running in Jupyter, which is pretty snazzy. All right, so future work. So I'm talking with the developer right now about renaming the thing that I created to VPython Piglet, just to give that as another option. However, I don't know, given that I changed all of the variable names to match Python styling, I don't know if that was a good idea or whether this will be possible now. I want to implement 3D text, and I also want to make sure that VPython Jupyter is compatible with what I've built. All right, so don't clap yet, because I have like 3 minutes left, and I want to talk about an experiment that I did. Instead of making a new release of Piglet helper, which, whatever, I guess I enjoy technical debt, so. The experiment is, why don't I take the distributed evolutionary algorithms package for Python and use scikit-image. And essentially what I'm going to do is try to evolve Piglet helper images to try to generate 2D images. So basically I feed Piglet helper into deep and then use scikit-image to compare against a specific image. And, well, it doesn't quite work yet because, and the reason for that is that there seems to be too high a penalty on matching white. So you can kind of tell looking at this. So it starts off with a whole bunch of images everywhere, and then it's like, oh no, there's a bunch of yellow. I can't, like, I put a bunch of dark-colored objects in there. I can't get rid of them. So right now it seems to be mostly just trying to move all of the objects into the blue part of the Python logo. But if anyone has any other ideas about how to do better, like, image matching so it looks like what a human thinks, that's like a really tough problem. Or we have some other ideas on the evolutionary algorithm side. Or we can even just see, I did some changes. And that's what it's doing right now on my computer. It looks like the thing is upside down, but at least it figured out that there's like a yellow sphere at the top and a blue sphere at the bottom. Yeah. Anyway, thank you.
Any questions?
I was just curious. I'm facing a very similar challenge. I'm a mechanical engineer trying to propagate Python at my workplace, and the kind of roadblock is good visualization, 3D mesh visualization. We do orthopedics. So I wonder, I've been looking at VisPy. I wonder if you've looked at VisPy, and if so, how does that fall in your little categorization of different libraries?
I'm sorry, I don't know VisPy.
Yeah, so I've used Piglet in the past, and I was wondering, I have problems using it with IPython, like not Jupyter, but just the IPython prompt. Like it'll run, the program works, and then when I exit, it just doesn't release, and I have to restart the whole kernel. Have you had that, or is it just me?
Yeah, I've encountered that problem too, and that's one of the things I want to do with making my library compatible with the VPython Jupyter. But I don't have a
Don't have an answer. Okay,
don't have an
thanks.
answer, sorry.
Are you able to export these visualizations to like MPEG format or MP4, something where you can upload it to the web or something like that?
So right now what I'm doing, I don't like to use video because I find that I have better luck just with animated GIFs, believe it or not, given all the different codecs and installing GStreamer and the extra codecs is a pain on Ubuntu. But you could definitely take the frames that can be generated by Piglet helper and just pass that to FFmpeg and generate your own video. And there's also a Piglet video submodule, but I have not used it yet. So that might be possible.
I think for your question on Travis on testing for the headless server, I think we have solved it in VPy. Well, right now I don't remember the solution, but we have it. So just send me email and I will explain or post an issue on VPy.
Okay, great, thank you.
And the other thing is that Piglet, it is still maintained? I don't think so, no? For Piglet. I think the creator of the Piglet package left the project.
Yeah.
And so is it still maintained by the contributors, do you know?
Yeah, so I've noticed that there is a distinct lack of updates to Piglet, and now that's another thing that I'm thinking about moving to PyOpenGL instead of using Piglet, just because PyOpenGL seems to be better maintained. And also, I suspect that it should be fairly easy to move everything over to PyOpenGL because they use the same syntax for everything, all the function primitives are the same. But I guess you're making a face, so I don't think, maybe you know something I don't.
Okay, I think this will be the last question.
Very short question. So have you thought about how to make this interactive, saying I want to drag and move around in the scene and explore it?
So, I disabled interactivity on that guy, but if I hadn't, so the default is, I think, I use the same defaults that Visual uses, which I think is left click drag or moves the camera around in the XY, XZ plane, and then the right click rotates the camera around the scene, and then the scroll one zooms in and out. So it's possible to interact with it that way.
All right, let's thank the speaker again.